Good evening, sir.
Ji Yusra, good evening. Sorry, I was not able to reply you.
Yes,
Yusra,
sir.
okay. So, Yusra, you have done the questions.
Sorry, sir.
You have done the homework. Any doubt in the homework?
Sir, I didn't do the complete homework. I started it.
Okay. So, any doubt till now?
No, sir.
Okay. Okay. Then we will wait for other students. Then we will start the class.
Sure, sir.
Hello, Safan. My voice is audible.
Yes, sir.
Okay, Safan, I'm waiting for the other students. So we will start the class in 3 minutes.
Okay, sir.
Okay. Okay. Safan, any doubt? You have done the homework?
Yes, sir. No doubt.
Okay.
I've seen the solutions on the NCERT site and completed.
Okay. Okay. Okay.
And yeah.
Okay. Good. Okay. So we will start the class. Okay. So we were doing the complex number. We have done the standard form. Okay. Now our next topic is conjugate of a complex number. Conjugate of a complex number. So Safan and Yusra, this chapter has been completed in your school.
Yes, sir.
Okay. And Yusra?
Yes, sir.
Okay. So in your school, did they teach you about the argument of a complex number? Because that is not in the syllabus, but in some schools they're doing that. So do you have any idea about that?
No, sir.
Okay. And Safan, do you have done the argument?
No, sir. I was not attending classes.
Okay. Okay. So conjugate of a complex number. Okay. So let Z be a complex number. Let Z be a complex number. Then its conjugate, and its conjugate is denoted by is denoted by this sign and given by, okay, let z is equal to a plus iota b. Okay, be a complex number, then its conjugate is denoted by this and given by this one, a minus iota b. So what is the conjugate when we have a complex number z is equal to a plus iota b and we are finding the conjugate, then we will just change the sign of this imaginary part. Earlier this was positive, so this become negative, and if in your question it is in negative, then convert that into positive. So if you need to find the conjugate of a complex number, then what you will do, you will just change the sign. Okay, so finally, Yusra.
Yes, sir.
Okay, and second thing, your complex number should be in the standard form. If the complex number is not in the standard form, then you need to convert that in the standard form. Okay, so
Yes,
please note down this definition and I will give you some questions.
done, sir.
Okay, very good. Then please note down this question. Find the conjugate of the following. So first is z is equal to 3 plus 4 iota. Second is z is equal to 3 minus 4 iota. Third, z is equal to 1 by 3 plus 4 iota. Please solve these questions one by one and share your answer.
So can you solve the first one and show?
Okay, so fine. So the first one is z is equal to 3 plus 4 iota. Okay, so z conjugate will be equal to what? We will change this sign. So this become 3 minus 4 iota. Okay, Safan, this clear?
Okay, sir.
Okay. So please try to do the second and third one and share your answer. Yusra and Safan, do you have completed the second one? Yusra and Safan, done the second?
Sir, is there anything we have to do?
Sorry?
Is there anything that we have to do in this question?
Yeah, please do this second one. Find the conjugate of this. Yusra, your answer is
Sir,
correct.
it's already in the
It is already.
okay.
There's a
In the
difference.
form,
Right?
right?
Okay. So what is z conjugate will be 3 plus 4 iota.
Okay.
Okay. Now
Okay.
please try to do the third part. Okay.
Sir, for the third one,
Yes.
do we only have to change the sign of the denominator or the numerator as well?
No, in the numerator, there's not an imaginary part. Okay. But first you need to convert this in the standard form. So Yusra, is this question in the standard form? Yusra, this is in the standard form or not?
Sorry, sir, I got disconnected actually.
Okay, not issue. I was saying that this question number third, this is in the standard form or not? Z is equal to 1 by 3 plus 4 iota. Is this a standard form?
No, sir.
No, this is not a standard form. Okay, so yesterday we have converted these types of question in the standard form. So how can we convert this?
Rationalize.
Rationalize. Very good. So first of all, convert this question in the standard form, then find the conjugate.
Okay, sir. Thank you, sir.
Okay, welcome. Safan, very good. So Safan, this is very good. This is correct. So Yusra, please share your answer. Then we will start the next question. Yusra, you have completed this. Uh, Yusra, you might have some network problem. So you can reply me on the chat box.
Sir, is it 3 by 25 plus 4 by 25 iota?
Very good. This is correct. So this is the third question. Please start the fourth one. Okay. Question 1 minus iota by 1 plus iota. You need to find the conjugate of this. Okay, Z is equal.
So where is the question?
Uh, the fourth part is this, the same question. Find the conjugate of the following. Okay,
Yeah, yeah.
there's a fourth one.
Okay, sir. Okay.
Safan, very good. This is correct. Yusra, please share your answer. Yusra, you have completed this. Very good. So Yusra, please write in this form 0 plus iota, okay? Because this is a standard form a plus iota b. Next, fifth, please try this question. Z is equal to 1 plus iota whole square by 3 minus iota. Okay, please find the conjugate of this. If anyone have any doubt, then please let me know. Okay, Yusra.
So 1 second, sir.
Okay. Yusra, what difficulty you're facing in this? You just need to open this bracket in the numerator and then again the same method. Okay, is there any doubt in this? Yusra, are you facing any doubt?
So is it -1/5 plus 2/5 iota?
-1/5 minus 3 iota by 5. So fine, your answer is correct. Very good. Okay, please check your calculation and confirm me.
Okay, yes, sir. It's 3 iota by 5.
Okay, very good. Then please try this question. This is a little tricky question. Okay, find the real numbers x and y if x minus iota y into 3 plus 5 iota is the conjugate of -6 minus 24 iota. Okay, this is your NCERT question. Please try this question and let me know if you have any doubt. Okay, there's a tricky question. So please try this. Safan and Yusra, any doubt in this question?
So do we have to open the brackets, multiply them first?
Yes, we need to do, but first we need to check that what condition is given in this question. So they are saying find the real numbers x and y. If this is the conjugate of this one. Okay, so this is the conjugate of this. So can we say that x minus iota y 3 plus 5 iota? Okay, I will give you a case that can we say this is equal to this? Is this correct or not?
No, sir, the sign should be changed.
Sign should be same. Very good, Safan. So can we say that this is the conjugate of this?
Yes.
Yes.
Okay. Okay, very good. Yes, Safan. Now you need to open this bracket. You need to change the sign, then equate the real and the imaginary part. That's all. Okay.
Okay, sir.
Good. Okay, Safan, I will help. So fun, you can separate the real and imaginary part. Okay, so we will open this bracket 3x 5 iota 5x minus 3y iota, and this is 5y and negative. Okay, and iota square will give you a negative, so this become positive. This is equal to minus 6 plus 24 iota. Okay, so this is a real part 3x plus 5y, and this is the imaginary part 5x minus 3y is equal to minus 6 plus 24 iota. Okay, Safan, we both are getting a different expression. Will you please check? You are getting a negative, I'm getting a this positive. I guess you have not changed with the sign
Yes,
over.
yes, sign over there.
Okay, and 5x minus 3, this is correct. So now this is the real part, this is the real part. So we will get 3x plus 5y is equal to minus 6. And we get a 5x minus 3y. And this is equal to 24. Okay. Now we have two equations. Please solve these two equations and share your answer. Yusra, this is clear? Yusra, this clear?
Yes, sir.
Okay, good. So fine and Yusra, if you have any doubt, then you can let me know. No, Safan, this is not correct. Okay, so let me solve this. We will make the coefficient equal. Okay, so we will multiply this with 5. And this second equation, we will multiply this with 3. So this equation will become 15x 25y is equal to minus 30. This 15x minus 9y is equal to now subtract this. This will cancel out. This will become 34y, and this will give you minus minus plus. So this will give you minus 102. Yusra, very good. This is the correct answer. y is equal to minus 102 by 34. So you will get this y is equal to minus 3. So find this clear?
Yes, sir. So I substituted for y.
Okay. So this is y is equal to minus 3. Please put this in any of the equation, 1 or 2. You will get the value of x. Okay. So please find the value of x and share your answer. No, Safan, this is not correct. Y is equal to minus 3. Okay, so put in this 3x minus 15 is equal minus 15 is equal to minus x. So you will get 3x is equal to minus 6 plus 15. So this will become 9. So x you will get 3. Okay, Safan? Is clear?
Yes, sir.
Okay, so please note down this, Safan, and confirm me, then we will start the next topic. This done, Safan?
Done, sir.
Okay. So next is properties. Okay, next is properties of conjugate. Next is properties of conjugate of a complex number. Properties of conjugate of a complex number. So what are the properties? So user, can you tell me if you will find a conjugate, and again we will find the conjugate of this. So what will be the answer?
It will be the same
The same one.
as
So,
the before one.
so this we will get the same complex number. So find this clear.
Yes, sir.
Now next is if we have two complex number and these two are in addition, okay, and we will find the conjugate, then this will be equal to Z1 conjugate plus Z2 conjugate. If there are two complex number and we are adding these two and we are finding the we are finding their conjugate, then that will be equal to separately we are finding the conjugate and we are adding it. Similarly in subtraction, Z1 minus Z2, if we subtract the complex number, we'll find its conjugate, then this will be equal to, if we'll separately find the conjugate and we will subtract it. Same property will be in multiplication. We have two complex number, we are multiplying this, then we are finding the conjugate. This will be equal to, if we will find the conjugate and we will multiply them. Similarly, same property, if Z1 by Z2, okay, we are finding the conjugate, then this will be equal to Z1 conjugate by Z2 conjugate. Okay. Next, third property. You will not be able to understand this sixth property right now. Okay, but we will do the modulus. After that, you will be able to understand that what is this. So please note down the sixth one. I will not explain you this right now. We will again discuss this property after the modulus. Imaginary part of Z whole square, and this is equal to modulus of Z square. Okay, Yusra and Safan, this clear?
Yes, sir.
Okay, so please note down this, then we will do some questions on the basis of the properties. Please confirm me once you note this.
Answer.
Okay, Safan, this is done.
One second.
Okay.
Done, sir.
Okay, Safan, then please try this question. If A plus iota B by C plus iota D is equal to X plus iota Y, prove that first is A minus iota B by C minus iota D is equal to X minus iota Y. Okay, first you need to prove this, then you need to prove this one. A square plus B square by C square plus D square, this will be equal to X square plus Y square. Okay, please try to do this question, and if you have any doubt, then I will help you.
So can you solve?
Yes, sure, Safan. So in this case, we have this A plus iota B by C plus iota D is equal to X plus iota Y. Okay, so we will check this one. We need to prove this. So Yusra or Safan, can you tell me from this one, how can we get this? Let this be one.
We'll find the conjugate.
Very good. Okay, so taking conjugate of one, taking conjugate of one, of one. So what this will become? This will become A plus iota B by C plus iota D. Okay, find the conjugate. And this would be equal to X plus iota Y and its conjugate. Sorry. We need to show the all the steps. So we are finding the conjugate. Okay, then this will be separated. You will separately find the conjugate of numerator. You will separately find the conjugate of denominator, because we have this property that Z1 by Z2, okay, conjugate, this is equal to what? Z1 conjugate by Z2 conjugate. Okay, just write this property. And this will be equal to, now what is X plus iota Y conjugate? This is X minus iota Y. Now, what is A plus iota B conjugate? This is A minus iota B. And this is what? This is C minus iota D. And this is equal to X minus iota Y. So this is proof, the first part. Okay, Yusra and Safan, this clear?
Yes, sir.
Yes.
Okay, now you understand this property, Z1 by Z2 whole conjugate.
Yes, sir.
Okay, very good. Now let this be second equation. Okay, now please try to prove the third part. Just give 2-3 minutes to this question. This is not a tough one. Just check from one by using 1 and 2. How can we get this? A square plus B square C square plus D square is equal to this one. Okay, please try to think. And if you have any doubt, then you can ask me. Yusra and Safan, you have any doubt?
Yes, sir.
Okay, then we will discuss this. We have this one, okay, and we have this second equation, and we need to prove a square. We will just focus on first on this part, a square plus b square. So in the numerator, we have a plus iota b. In the second one, we have a minus iota b. So what property can we apply so that we will get a square plus b square? Any idea?
So we can do it by when we rationalize and there's in like a
But
plus b the whole square. No, no.
okay, but if you will rationalize this, then in the denominator you will get a minus iota b. In the numerator, that's correct. In the numerator, you will get a square plus b square. Okay, but in the denominator, you will get a minus iota b.
Yes.
Yes, sir. So that will be an additional term. I know.
Yeah.
So okay, we will not be able to adjust that term then. Any other idea? You're very close to the solution. Any other solution you
We'll
trying
just
to?
square the.
We will square. No, we will not be able to get this. Okay, I will
If we
show you.
multiply this with the
Very good.
same thing.
Very good. Great. This is correct. If we will multiply 1 and 2, we will get this expression. Okay, because this is a plus iota b, this is a minus iota b. And when you will multiply this, you will get a square minus b square form. And finally, you get this. Okay, very good, Yusra. So, Safan and Yusra, please try this. Multiply 1 and 2. Okay, multiply 1 and 2. Please do this and confirm that you get the answer. Yusra and Safan, this done.
1 second.
Okay.
Done, sir.
Done, sir.
Okay, very good. Then please try this question. This question is in your NCERT. If a plus iota b, a plus iota b, this is equal to x plus iota whole square 2x square plus 1. Prove that a square plus b square okay. So please try this question by the same method. Okay. So, and if you have any doubt, then please let me know.
Sir,
Yes, Shusra.
do we have to do it in the same way, like first take out the conjugate and then multiply both of them?
Yes, yes, same method.
Okay.
So do you have to square the x plus 1? This is the whole square. So do you have to open?
No, no, there's no need. So if we have this a plus iota b, and this is equal to x plus iota whole square by this is 2x squared plus 1. Okay, let this be first. So what you will do, you will find a conjugate, taking conjugate of 1. So what you will get, a plus iota b conjugate is equal to x plus iota whole square conjugate by 2x squared plus 1. Okay, so or you can show that. Okay, just take a complete bracket. Okay, so from this you will get 1 minus iota b, and from this what you will get, x plus iota conjugate. Okay, and this is whole square by this is 2x squared plus 1 conjugate. Now this will give you a minus iota b, and this will give you x minus iota whole square. Okay, and because there's a real part, so there will not be change in the sign. We only change the sign of imaginary part. Okay, Safan?
Okay, sir.
There's a second. So now just multiply 1 and 2 and you will get your answer. Still, if anyone have any doubt, then please let me know. Yusra, this is completed.
Doing so.
Okay, okay. If anyone have any doubt, then let me know.
So in the last part, when you multiply the conjugate and in the original one,
Yep.
so in the denominator we're getting 2x squared plus 1 into 2x squared plus 1.
Okay. So we have this a plus iota b. Okay. We will multiply this with a minus iota b. In the RHS, we have this x plus iota whole square, x plus iota whole square by 2x square plus 1. Okay. And in the second one, we have this x minus iota whole square into 2x square plus 1. So what we can do, this can be written as a square minus iota b whole square. You don't have any doubt in this. Now in this case, you have a doubt. So what we will do, because the power is same, as the power is same, so we can write this as like this, x plus iota, x minus iota whole square. Okay, and this can be written as 2x square plus 1 whole square. Okay, Yusra?
Yes, sir.
Safan, this clear?
Yes, sir.
Okay, so now please complete it.
Done, sir.
Okay, very good. Yusra, this completed?
Yes, sir.
Okay, good. So we will then start the next topic. Next is modulus. Okay, modulus of a complex number. Let Z be a complex number. Then its modulus is given by, sorry, is denoted by let Z is equal to a plus iota b, denoted by mod of Z and given by mod of Z is equal to mod of under root of a square plus b square. Okay, or modulus of Z is equal to under root of real part of Z square plus imaginary part of Z whole square. Okay, so Yusra and Safan, this clear?
Yes.
Yes, sir.
So if Z is equal to a plus iota b be a complex number, then modulus will be equal to under root of a square plus b square. What is a? A is the imaginary part. Sorry, a is the real part. And what is b? B is the imaginary part. We'll take example. For example, we have this Z is equal to 3 minus iota 4. Suppose we have this, we need to find the modulus of Z. Then what will be the answer? 3 square plus, okay, not minus, plus 4 square. So this will give you 9 plus 16, and this will be equal to under root 25, and this will be equal to 5. Okay. So here there is a negative or positive, that doesn't matter. We just need to take a real part, we need to take an imaginary part, we need to do their square, and we need to add them. Okay.
So why do we change the sign?
We have not changed the sign. What is the formula? Formula is under root of a square, and this plus sign is in the formula. This always
Okay,
remain
so-
positive. Okay.
So it doesn't matter if the number is positive or
Yes.
negative.
Yes, it doesn't matter. So from the question, we just need the value of a and b. We don't need the sign.
Okay, so
Okay. Okay. Safan, this clear?
Yes, sir.
Okay, very good. So please note down this and try this question. Find the modulus of the following. Find the modulus of the following. So first part, z is equal to 12 plus 5 iota. Second part, 3 z is equal to 3 plus iota 4. Okay, please try these two questions and share your answer. If you have completed the first part, then you can share your answer. Safan, very good. This is correct. Please try the second one. Good, Safan. Yusra, this completed. Yusra, you have completed the first and second one.
1 minute, sir.
Okay. Please share your answer once you complete it. Yusra, very good. This is correct. Very good, Yusra. Now we will start the next topic. Next is properties. Okay. Next is properties of modulus. Properties of modulus of a complex number. A complex number. Okay. So what are the properties? First properties is if we are finding the modulus of Z, or we are finding the negative of Z, or we are finding the conjugate of Z, then the answer will be same. You know, we have already checked this, that we just need the value of A and B irrespective of the sign. Okay, so Fan and Yusra, this clear?
Yes, sir.
Now the second property is same like that of conjugate, that if two complex number are in division and we are finding the modulus of this, then this will be equal to modulus of Z1 by modulus of Z2. Okay, Rishan. Some topics you have missed, so that's not an issue. Yes, Nirkash, please ask Nirkash sir. He will share the recorded lectures with you. Okay. Yes, he will share the link with you. Okay. So Rishan, please be
So,
there.
sir,
Yes, Yusra.
modulus is always positive, right?
Yes. Okay, so mod of Z is what? Actually, this is under root of A square plus B square. Now this quantity is always positive. This is always positive, and there is a positive sign. So this will be always positive. Okay, and Rishan, please be there in the class. We will start a new topic and you will able to understand that. Okay. So we are discussing about the modulus. We have this property. Then we have this Z1 into Z2. Two complex number are in multiplication. We are finding the modulus of this. So this will be equal to modulus of Z1 and modulus of Z2. Okay. Now fourth property. This we have already noted in the conjugate, but I will explain you this. Z into Z conjugate. This is equal to modulus of Z square. Okay, and this is equal to is real part of Z whole square plus imaginary part of Z whole square. Okay, so we have this property. Now we will prove this one. Let Z is equal to A plus iota B. Then Yusra, what is Z conjugate?
A minus
A minus iota B. Okay, let this be 1, this be 2. Multiply 1 and 2. Multiply 1 and 2. So what you will get? Z into Z conjugate, and this will be equal to A plus iota B and A minus iota B. And this will give you what? Z into Z conjugate. This is equal to, this is A plus iota, this is A square minus, this will be equal to A square minus iota B whole square. So this will give you Z into Z conjugate. This is equal to A square. Iota square will give you a negative sign. This become positive. So Z into Z conjugate is this. So we can also say that this is what? This is a modulus of Z square. Okay, so this is a very important property, that Z into Z conjugate is equal to modulus of Z square, or we can say real part of Z or plus imaginary part of Z whole square. This is not a new thing. Modulus of Z is root. So when we are doing the square, then root will remove. So Safan and Yusra, this is clear. The fourth property.
Yes, sir.
Safan.
Yes, sir.
Okay, so please note down these properties and confirm me. Then we will do some questions and we will start a new topic, multiplicative inverse. Okay, so please note this and confirm. Please let me know once you complete this, then we will start the questions. Yusra, this is done.
Yes, sir.
Done, sir.
Done.
Okay, Rishan, shall we start next? Rishan, shall we start next? Rishan, I am not getting the reply, so I guess you already have noted this. Okay, so we are starting the questions. Okay. Okay, Rishan, I got your reply. So question is, if alpha and beta, if alpha and beta are or different, complex, numbers with mod of beta is equal to 1. Okay, this is from the NCERT miscellaneous. Mod of beta is 1, then find beta minus alpha by 1 minus alpha conjugate beta. Okay, you need to find the value of this one. This is from the NCERT miscellaneous. Please think for 2-3 minutes, then I will give you the hint. Shall I give you the hint?
Yes, sir.
Okay, so we need to find this value, and directly not possible for us to find the value of this beta minus alpha conjugate beta. If we will do the squaring, then Yusra, can you tell me in the right side what we can write? This completes a complex number. Okay, alpha and beta are different complex number. So this completes also a complex number. And if we are, and this is a modulus, and if you are doing the squaring of this modulus, can you tell me what is the right side of this? Uh, please check this one, this property. So modulus of z square is equal to what? Z into z conjugate.
Yes, sir.
Okay. Safan, this property is clear.
Yes, sir.
Okay, so Rishan, you will not be able to understand this one, okay, because some portion you have missed. So please wait, we will start a new topic after this question. So can we say this is equal to beta minus alpha by 1 minus alpha conjugate into beta? Okay, there's a complex number, and beta minus alpha by 1 minus alpha conjugate into beta conjugate. This is clear or not, Safan and Yusra?
Yes, sir.
Yes.
Okay, now can you solve this? You just need to multiply these two. First, you need to find the conjugate of this. Then you need to multiply this. Okay, then please share your answer. And still, if you will face any issue, then please let me know. I will help you in solving this.
So what will we do about the alpha conjugate already we have over there, right?
Okay, then I will solve. I will do the other step also. Okay, beta minus alpha 1 minus alpha conjugate beta whole square. This will be equal to, this is beta minus alpha by 1 minus alpha conjugate beta into, this is beta conjugate minus alpha conjugate, and this is 1 minus. Okay, yeah, in this, for this one you don't need to take the any conjugate, but because there's a real number, there's a conjugate, and you have this beta and you have this conjugate. So these two are in multiplication. You will write the conjugate separately on this complex number. So if there is a conjugate and double conjugate, then what is the answer? So far, we have already
Uh,
done this in the property. This one.
yeah.
Okay, so we will get the same number, same complex number.
Okay.
So please try to do this.
So
Yes, Yusra.
in the RHS, the second one where we have
Yusra, I will switch off my video. Maybe that will help. Yusra, I can't hear you. You can message me on the chat
yes,
box.
sir.
Yes.
So there is 2 times conjugate on alpha. So will it be
Sorry, Yusra, I'm not able to understand your doubt.
like what are we supposed to do if there is 2 times conjugate? Because
So,
on alpha
yes,
they,
yes. Yes, so what is ZZ conjugate?
it's z.
Is it? So alpha alpha conjugate is again alpha.
Okay.
So this will give us 1 minus alpha conjugate beta, and this is beta conjugate alpha conjugate by 1 minus alpha into beta conjugate. Okay, so just multiply this, open the bracket, and hopefully you will get the answer. If you need any help, then you can let me know. So this will be beta into beta conjugate, alpha conjugate into beta minus alpha beta conjugate plus alpha into alpha conjugate. Next is 1 minus alpha beta conjugate minus alpha conjugate beta plus alpha into alpha conjugate beta into beta conjugate. So beta minus alpha 1 minus alpha conjugate beta whole square, this would be equal to so Yusra Savan, please check here. Just give me a minute. Yes. So Yusra Safan, please check here. This step is clear.
Yes, sir.
Safan, this step is clear.
Yes.
So beta into beta conjugate, can we write it as beta modulus whole square?
Yes, sir.
Okay, Safan, this clear?
Yes. Yes.
Minus alpha conjugate beta. Okay, this as it is, minus alpha beta conjugate, this as it is. Now alpha into alpha conjugate, this can be written as alpha modulus whole square. Again, same property. In the denominator, we have 1 minus alpha beta conjugate minus alpha conjugate beta. Now this again, okay, this alpha into alpha conjugate, this again can be written as, I will write over here, alpha whole square modulus whole square, beta beta conjugate is modulus of beta whole square. Now Savan, can you tell me that what is the value of modulus of b, modulus of beta?
1.
1. So please put the value 1 over here, okay, over here and here. Then you will see the numerator and denominator are exactly same. You can cancel the numerator and the denominator. Okay,
Okay.
please note down this. Try to do this now. Okay, just put b modulus of beta is equal to 1 and hopefully you will able to get the answer. And still, if you have any issue, then please let me know. I will help you. Safan, very good. Very good. This is correct. So, Yusra, do you get the answer? Safan is find out the answer. Beta minus alpha by 1 minus alpha conjugate beta whole square. This is equal to 1. Okay, Yusra, you are getting the same one? Okay, okay.
Yes, sir. I've messaged you.
Okay, very good. So now this is a modulus squares. Okay, so we need just the modulus. So what we will do, we will take a root. So this, I don't have the space. So beta minus alpha by 1 minus alpha conjugate beta. We just need the mod. So we will find out the root. So that will be equal to 1. We will not write plus minus 1. Okay, because the modulus is always positive. So we can't write plus minus over here. We will just write a positive. So the value of this is 1. This clear? Safan and Yusra?
Yes, sir.
Okay. So please write this answer and we will start a new topic. Okay. It will just take a 5 minutes. Okay. Shall we start? You have noted this?
Yes, sir.
Okay. So next topic is multiplicative inverse. Multiplicative inverse. Okay. Let Z be a complex number. Z be a complex number, then its multiplicative inverse, inverse is given by is given by 1 by Z. Okay. So if a complex number is given and you need to find the multiplicative inverse, then what you will do, you will just do the reciprocal of that. Okay, that's, you don't need to do anything else. Just do the reciprocal of that. Any doubt in this? Safan, Yusra, Rishan?
No, sir.
Okay. So this is 1 by Z, but we already know that we always find, uh, let's take examples. For example, Z is equal to 3 plus 4 iota. Okay. So what is the multiplicative inverse of this? 1 by Z, which is equal to 1 by 3 plus 4 iota. But we already know that we always write the answer in the standard form. So this is not a standard form. What we will do, we will rationalize this. 3 minus 4 iota, 3 minus 4 iota. So this will give us 3 minus 4 iota by this 3 square minus 4 iota whole square. So this will give 3 minus 4 iota by this is 9 minus 16 iota square. This will give us 3 minus 4 iota and this is 9 plus 16 and this will give you 3 minus 4 iota by 25. Okay, and then you if you wish you can separate this 3 by 25 minus 4 iota by 25. Okay, so we need to change this in the standard form. So if 3 plus 4 iota, then what is 3 minus 4 iota? Yusra, what is the relation between this? Z is equal to 3 plus 4 iota and what is this 3 minus 4 iota? Conjugate.
Yes, sir.
So this will be equal to Z conjugate by, Yusra, can you tell me what is this 25?
20.
Can we say this modulus of Z square? Okay. So we
Yes,
have
sir.
one more formula. Multiplicative inverse of Z is given by 1 by Z. Then we need to convert that in the standard form. Or if you wish, you can just directly write down this formula that 1 by Z is equal to Z conjugate by modulus of Z whole square. Okay. So this is a new topic and we will discuss further questions on the basis of this topic in the next class. Okay, so just give me a minute, I will give you the homework. This is your homework, okay? And if in a question you get an argument, then please ignore that. Do not find the argument. That we will do in the next class. Okay, please wait. I will give you the homework from the assignments. So from the assignment 1, I have already told you. Next is from the assignment 2. Assignment 2. So the homework is again question number 1, 2. Question number 1 to 12. Question number 1 to 24. Okay. So this is your homework and we will discuss your doubts in the next class. Okay.
Okay, sir.
Okay. Okay.
Thank you, sir.
Okay, you're welcome. And Rishan, you can take the link from the NetCursor regarding the recorded lectures. Okay. Okay then. Thank you. Okay, Rishan. Thank you.